Hi Algebra 2 students. This is a quick video to show you how you get started on problems 15 and 16 in your homework. So first we'll take a look at 15. So in 15 it says a communications tower is located at the top of a steep hill. So it's hard to see in the picture, but the idea is that the steep hill is kind of like this, going up. And then it says the angle of the inclination of the hill is 67. So that's this 67 down here. A guy wire is attached to the top of the tower and to the ground 165 meters downhill from the base of the tower. So the guy wire is right here. Okay, so we're kind of like thinking about this orange triangle, and the wire is this side. And then we know like this side length is the 165 meters, and we have the 16-degree angle. Then it says the angle formed by the guy wire is 16 degrees. Oh, that's there. Find the length of the cable required for the guy wire. So that means we're going to need to find the length of this side. So if it helps you think about the problem, you could label your angles like A, B, C. In which case we would need to find this would be side little b, right? Now, right now we only have one angle and one side in this orange triangle, but we also have this 67 degrees down here, and that's going to come in handy because I can kind of extend this line straight down, where the tower is, and create this little right triangle here. And that's a useful the purple right triangle is useful because if I know my angle right here is 67 and I know this is 90, that means I can find the third angle in that right triangle by subtracting from 180. So I can do 180 minus 90 minus 67, and I get 23. So if that's telling me this green angle down here, but that also gives me information about the orange triangle because the green angle, 23, is a linear pair with the orange angle B, right? So if I want to then find angle B, that's going to be 180 minus 23, or 157. So now I know my angle B is 157, and I have angle, side, angle. So I'm going to be setting up law of sines. And remember, like, once I get this as 57, and now I already knew this is 16, that means I can find my final angle up here also, because if I have two angles, I can always subtract them from 180. So I'm going to get this angle up here to be 7 degrees when I do that subtraction. Okay, and then from there, again, you're setting up law of sines. So now let's take a look at 16. 16's picture is kind of crazy, especially because it did not copy very well. But the idea is we have a roof that's slanted at 20-degree angle, and so that's this bottom angle here. So what you can't quite see in the way it copied is that there's an incline of the roof. It kind of goes like this. And so that's the roof. And then there's a solar panel attached to the roof. That's what's happening right here. So this kind of darker line up there, that is a solar panel. This purple line I'm about to draw. That's the solar panel. And then it has an angle of elevation at 38 degrees off of that straight horizontal. And we're trying to figure out what's the length of this little support, this little vertical support there. So like the triangle we're thinking about is this kind of purple triangle sitting atop the orange one. And now again, it's going to be useful for us to think about the orange one as being part of a larger right triangle. Okay, because if this is 20, this is 90, we can start kind of building our way to getting a couple more pieces of information about the purple triangle, because I can get the third angle in the orange triangle by doing 180 minus 90 minus 20 and getting 70 degrees there. So if this angle is 70, then now I can get this purple angle up top as being 180 minus 70, or 110. Okay? And now I have this angle and the side across from it, right? And I also, now the 38 degrees, this is the part that's really probably the most confusing part about this problem, is 38 degrees is not this small angle right here in this triangle, because it's actually a little bit larger. Notice, like, let me see if I can do this visually. Like, if my pen represents the angle, I want the angle from this line to the edge of the roof, but that's not 38 degrees. 38 degrees goes all the way to the horizontal, that horizontal dashed line. So the key to figuring this out is that if this angle in the corner is 20 degrees, then there's also like an corresponding angle up here that's 20 degrees. So to get the angle in the smaller triangle on top, to get, like, I'm going to highlight it in green, to get this angle, that's actually 38 degrees minus 20. So 18 degrees is what goes in this in the smaller triangle. So if I call this side, like, if I call this angle A, this angle B, and this angle C, then I'm doing sine of 110 over 8 is equal to sine of 18, because that's the angle right here in the small purple triangle, over little a, because that's what I'm trying to find, that support. So once you solve this, we should arrive at our answer. So I hope this video helps you guys get started. Have a great rest of your week, and do the best you can in class on Wednesday and Thursday, and I'll be sure to answer all your questions when I see you guys the following week.